Alright guys, let's have a look at these problems. Write the first 5 terms of the sequence. Okay, so start with n equals 1. So what is that? Sine pi by 2 when n is 2. Sine 2 pi by 2. Keep going until you have reached the 5th term. Okay, the 2 is strictly part of the input. Okay, you're not dividing the sine function. Alright, the 2 is part of the input. Now go ahead and tidy up. Sine pi by 2 is 1. This becomes sine pi 0. That is negative 1. Sine 2 pi is 0. Sine 5 pi by 2 has the same value as sine pi by 2, right? Because you have gone around a complete circle and pi by 2 radians after that. So sine pi by 2 is 1. Okay. List the first 5 terms here, guys. When n is 1, negative 1 squared, 2 over 1. When n is 2, negative 1 cubed, 2 over 2. When n is 3. When n is 4. When n is 5. 5 plus 1 is 6. Alright, tidy up. That's 1 times 2. Negative 1 times 1. 1 times 2/3. Negative 1 times a half. This is 1 times 2/5. Those are the first 5 terms. Match the sequence with its graph. Okay, 10 over n plus 1, right? So clearly, guys, as n increases, the terms of the sequence should decrease. So here the terms are increasing. Here they are decreasing and increasing. Here too, they are constant. But the terms of the sequence are decreasing in C. And guys, when you see the graph of a sequence, you will notice that the dots are not connected. Connecting the dots does not make sense. When you are connecting, say for example, if you are connecting here, you are including the region between 3 and 4. For example, 3.5. But n can't be a fraction. N has to be a whole number. So the dots of a sequence are never connected. Keep that in mind. Okay. Next. Here, guys, have a look at this. This is 10n over n plus 1. For very large values of n, as n goes to infinity, what is the limit of this nth term? The numerator and denominator have the same power. The limit of that is going to be 10 to a very large n, right? So that is going to be, guys, a, because as n keeps on increasing, the sequence is going to level off at the value 10. So that has got to be a. Okay, negative 1 to the power n. This seems like an oscillating sequence or an alternating sequence. When n is 1, the value is negative 1. When n is 2, the value is negative 1 squared, which is 1. When n is 3, back to negative 1. When n is 4. So it's going to be D. And lastly, this has got to be B, right? Why is that? Again, it's alternating. When n is 1, negative 1 over 1 is negative 1. When n is 1, you get negative 1 over 1. That's negative 1 right here. Sorry, that is n equals 1. The value is negative 1. When n is 2, negative 1 squared is 1. 1 over 2 is 1/2. When n is 2, the value is 1/2. Okay? Have a look. When n is 2, the value is right there. So it makes perfect sense. That is B. Write the next 2 terms, guys. The sequence is increasing by 3, so it's going to be 14 and 17. What about this? 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40, 40 times 2 is 80, 80 times 2 is 160. We're asked to write the next 2 terms. simplify the ratio of factorials. Now, if you guys are new to factorials, you might need a bit of review or introduction of the material. So guys, have a look. 2 factorial is 1 times 2. 1 factorial is simply 1. And please remember guys, 0 factorial by definition is also 1. 3 factorial, 1 times 2 times 3. 4 factorial, 1 times 2 times 3 times 4. That's how factorials work. You can keep on going. Notice that guys, for example, we can condense 4 factorial into, remember 4 factorial is 1 times 2 times 3 times 4. But we know 1 times 2 times 3 is 3 factorial times 4. And the other part is times 4. Similarly guys, 5 factorial is 4 factorial times 5. 6 factorial is 5 factorial times 6. And what is this going to be? So n plus 1 factorial. Look at the number before n plus 1. That's going to be n. So it's going to be n factorial times n plus 1 over n factorial. N factorials cancel and the result is n plus 1. Okay guys, now look, why is that? 4 factorial is 3 factorial times 4. 5 factorial is 4 factorial times 5. 6 factorial is 5 factorial times 4. So n plus 1 factorial is n factorial times n plus 1. Okay? Now, let me have a look. Hey guys, you can write 7 factorial as 5 factorial is 1 times 2 times 3 times 4 times 5. And after that, you need 6 and 7. Right? So guys, you can always write a larger factorial using smaller factorials. Of these two, the larger factorial is the denominator one. So keep the numerator factorial just like that. 2n plus 1 factorial is in the denominator. Let's try and write it using the smaller factorial. Smaller factorial is 2n minus 1 factorial. But to go to 2n plus 1 factorial, we need the number after that, which is 2n, and the number after that, which is 2n plus 1. Okay? So these cancel. So you have 1 over 2n times 2n plus 1 when it's simplified. Alright guys, remember, the difference between 2n minus 1 and 2n plus 1 is 2 numbers. The numbers in between are 2n and 2n plus 1. Find the limit, if possible, of the sequence whose nth term is given there. So limit as n goes to infinity of an, the nth term, which is limit as n goes to infinity of 5n squared over n squared plus 2, which is going to be 5. Okay? Find the limit of this. So we want the limit as n goes to infinity of 2n over square root of n squared plus 1. Now guys, think about it. Now, when n goes to infinity, it's the largest power that matters both in the numerator and in the denominator. In the numerator, the largest power is 1. In the denominator, you have n squared, and that is inside the square root. Okay? Now, when n goes to infinity, the smaller terms are negligible. Plus 1 is negligible. So this is square root of n squared. When simplified, it becomes n. Now guys, you have 2n over n. When n goes to infinity, that limit is 2. Okay? So remember, when n goes to infinity, keep it as 2n. Come down here, ignore the smaller powers, ignore 1. This becomes square root of n squared. When simplified, you get n. So 2n over n will give you 2. Determine the convergence or divergence of sequence with the given nth term. If the sequence converges, find its limit. Okay, so let's find the limit as n goes to infinity of the nth term. that is limit as n goes to infinity of 5 over n plus 2. That limit is 0. And this is a finite number. So we say the sequence an converges. Alright guys, determine the convergence or divergence of this sequence. Now the presence of negative 1 to the power n indicates that the terms are going to be alternating in sign. So guys, you might say, let's make all the terms positive by absolute valuing it and finding the limit of the absolute valued sequence. Makes perfect sense, so I will write if we used the absolute value theorem, then what do we have? Limit as n goes to infinity of the absolute value of an is limit as n goes to infinity of negative 1 to the n over n plus 1. Now, when you absolute value, all the terms become positive, so negative 1 to the power n disappears. This turns into this. They both have the same powers. That limit is going to be 1. But the problem is, the absolute value theorem says if the limit of the absolute value is 0, then the limit of the nth term without the absolute value is also 0. But this is 1, not 0. So I would say absolute value theorem is inconclusive. Alright, then how are we going to find the limit of that sequence? Alright, so what we are going to do is, we are going to find the limit as n goes to infinity of an. Guys, you will notice that some terms are going to be positive, some terms are going to be negative, so the terms are going to be oscillating. And the terms are not going to be approaching a particular value. Okay, so I would write the limit as n goes to infinity of the original an does not exist. Okay, so the sequence an diverges. Alright, why does it not exist, guys? Because you can list the terms. Some terms are positive, some terms are negative, so it's going to go negative, positive, negative, positive, negative, positive. It's not going to go toward a particular value. Okay, the next one is easy. What is the limit of this sequence? Find the limit as n goes to infinity of an. And guys, this is an. What is that limit? Both top and the bottom have the same power. So the limit at infinity is going to be coefficient of the leading power divided by the coefficient of the leading power. That is 5. So we would say the sequence an converges. Okay. Alright. Next. What is the limit of this? Alright guys, you know that an can be written as 3 times ln n over 2n. The cube is on n, so using the power rule for logs, we can bring the 3 in front. Alright, so we want to find the limit as n goes to infinity of 3 ln n over 2 times n. As n goes to infinity, direct substitution will yield infinity over infinity. So limit as n goes to infinity of 3 times 1 over n over 2. That's going to be limit as n goes to infinity of 3 over 2n. And as n goes to infinity, that is going to go to 0. So we had to apply L'Hopital's rule only once. And because that limit is 0, it's a finite number. So we will say sequence an converges. Okay. What is the limit of this sequence? Let's tidy this up. How do we tidy this up? Always write the larger factorial using the smaller factorial in question. The smaller factorial in question is n factorial. So n plus 1 factorial is n factorial times n plus 1. Okay? So that is simply n plus 1. So you want to find the limit as n goes to infinity of an, which is same as limit as n goes to infinity of n plus 1. That limit is infinity. So what do we have? So that means the sequence an diverges. Alright? Now, determine the convergence or divergence of this sequence. Go ahead and find the limit as n goes to infinity of an. That turns it into the limit of 2 to the power 1 over n. As n goes to infinity, guys, 1 over infinity is 0. So that turns out to be 1. So we would say an converges. Okay? Now, what is the limit of this? Now, guys, this is a very special function, sine n over n. Okay? Sine n is going to be oscillating between -1 and 1. Right? So it's an oscillating function. So this is a very good example for squeeze theorem, guys. So sine n over n, the maximum value for sine n is 1. The minimum value for sine n is -1. Okay? Now, you want to find the limit of sine n over n as n goes to infinity. Take the limit as n goes to infinity of 1 over n here. Take the limit as n goes to infinity of -1 over n. 1 over infinity is 0. And if you're not sure about the middle limit, just leave it there. What is this limit? 0. Both these values are the same. So we will write by squeeze theorem. Okay, limit as n goes to infinity of sine n over n is 0. So what does that tell you about the sequence, guys? The sequence converges. So I will write the sequence an converges. Okay? Now, in the next question, what I have for you is a set of numbers separated by commas. Write the expression for the nth term of the sequence. In other words, you have to come up with a formula for the nth term. Now, it may not be easy, guys. It's okay if you can't get it the first time around. Okay? Now look, 2, 8, 14. Nth term for this is 6n minus 4, guys. How do we know that? When n is 1, 6 minus 4, 2. When n is 2, 12 minus 4, 8. When n is 3, 18 minus 4, 14, so on and so forth. Right? Okay, you will get that by some trial and error. Now look at this. There is a relationship here. Now we know the perfect squares are 1, 4, 9, 16, 25, 36, right? Don't you guys think all these numbers are 3 less than the perfect squares? So perfect squares are n squared. 3 less than that would be minus 3. You guys seeing that? See, 1 squared is 1 minus 3 negative 2. 2 squared is 4 minus 3, 1. 3 squared is 9 minus 3, 6. 4 squared is 16 minus 3, 13. Okay? Now, this one is an easy one. Now, the numerator 2, 3, 4, 5, increasing by 1. So it's going to be n plus 1. Denominator 3, 4, 5, 6, increasing by 1. Does it make sense? When n is 1, 1 plus 1, 2. 1 plus 2, 3. When n is 2, that's going to be 3 over 4. When n is 3, 4 over 5. Okay? Alright guys, in this question what I want you to do is determine whether the sequence with the given nth term is either always increasing or always decreasing, and also determine whether it is bounded. What does bounded mean? That means the sequence is both bounded above and bounded below. Okay? So guys, what you can do is list a bunch of terms. Okay. Now, first term 4 minus 1, second term 4 minus a half, 4 minus a third, 4 minus a fourth, 4 minus a fifth, so on and so forth, right? So what are we going to have? That's going to be 3. 4 minus a half, that's 3 and a half, right? 4 minus a third, 3 and 2/3. 4 minus a fourth, 3 and 3/4. 4 minus a fifth, 3 and 4/5. Is that right, guys? So look, isn't this increasing, guys? 3.5, 3.666, 3.75, 3.8. Now, when n gets increasingly large, when n goes to infinity, 1 over infinity is 0. What's the last term going to be? Last term is going to be 4. Right, guys? So this sequence is bounded below by 3, bounded above by 4, and because it's both bounded below and bounded above, we will say an is bounded. Okay, and is it always increasing, guys? Yes, the values are always increasing from 3 to 4. Okay, that's all you had to say there. And you know what the theorem says, right? If it is bounded and monotonic, the sequence is convergent. And you can easily see that. When you take the limit as n goes to infinity, 4 minus 1 over infinity, 4 minus 0 will give you 4. The limit would be 4. Okay, let's have a look at this guy. Your an, when rewritten, looks like n over e to the power n over 2. Plug in some numbers. A1, 1 over e to the power 1/2, that is 0.6065. Give me another one. A2, 2 over e to the power 2 over 2, 0.7358. A3 is 3 over e to the power 3/2, that's 0.6694, so on and so forth. So guys, have a look at the terms of the sequence. Are they always increasing? No. They started off by increasing, and then there is a decreasing value, right? So for that reason, it is not monotonic. Now, is it bounded? So guys, if you kept listing, you will soon see a pattern. I mean, not a pattern, you will soon notice that this function eventually goes to 0, guys, because as n goes to infinity, e to the power n over 2 goes to infinity faster than n. Exponential grows faster than polynomial. Eventually, it's going to go to 0. So it's going to be bounded below by 0. Eventually, it is going to go to 0. Bounded below by 0. And guys, believe it or not, it is bounded above as well. You just have to keep listing a few more terms to see that no value will be larger than 0.7358. Okay, so it's bounded above as well. So because it's both bounded below and bounded above, we say the sequence is bounded. Alright, so we will go ahead and say an is bounded. Okay, have a look at the next problem. An equals 2/3 to the power n. Okay, let's list some, shall we? First one is 2/3. Second one is 2/3 squared. Third, 2/3 cubed. Okay, guys. So if you don't know what these values are, guys, look. This is 2/3. This is 4/9. This is 8 over 27. Right? So guys, always decreasing. It's always decreasing, guys, because the denominator is larger than the numerator. Always decreasing. Okay. Is it bounded? It's always decreasing. So eventually, guys, it's going to go to 0. Bounded below by 0. And what's the largest value there? That's the first value. Bounded above by 2/3. Because it's both bounded below and bounded above, we say the sequence AN is bounded. Remember the definition of a bounded sequence. A sequence is said to be bounded if it is both bounded below and bounded above. Okay, and you have one more question before we wrap up this section. Is this sequence bounded? What is A1 when n is 1? When n is 1, this is sine pi by 6, that's 1/2. A2 when n is 2, sine 2 pi by 6, that is same as sine pi by 3, that's √3/2. When n is 3, that's 3 pi by 6, which is same as sine pi by 2, that is 1. Alright guys, is it always increasing or always decreasing? No, it started to increase. √3/2, guys, if you are wondering, that's about 0.866. So it started to increase from 0.5 to 0.866, and then it decreased. Oh, beg your pardon. Beg your pardon, guys. So it's starting to increase 1/2, 0.5 to 0.866, and then to 1. Now let's do A4. What is A4? Sine 4 pi by 6, which is same as sine 3 pi by 2, that is √3/2, which is 0.866. So guys, notice what's happening here. 0.5, 0.8661, and then down to 0.866. So it's not always increasing. Okay? Because it's not always increasing or always decreasing, we will say it's not monotonic. Is it bounded? What do we know about sine function? It's a sine function, right guys? The maximum value for sine is 1. The minimum value for sine is -1. Okay, because the sine function has a maximum and a minimum, it has an upper bound and a lower bound, and the sequence is bounded. Alright guys, that is the end of 9.1. Please go ahead and finish your homework, and please guys come and see me if you have any questions.